Accepted.
Okay, so let's start. Hello everybody, thank you for joining me here today. My name is Modrzejewska. I'm a senior software engineer and product owner at Dynatrace. I've been working as an engineer for the last 14 years, from which 10 I worked on solutions connected with log monitoring. And this is also the topic I would like to talk about today. So how to get answers from your log data that at first sight could look like a noise. So let's start with a statement that data is not enough. So just having the data stored somewhere without proper tools to analyze it is not enough. It may work when we have just a couple of data points, then it's very easy to draw some conclusions after looking on them briefly. But in case of more complex systems, it takes a lot of time and a lot of manual work to just get some insights from the data. So, do you have any idea what is shown here? Apparently, it's a Pokemon, but I tried to connect those dots, but I didn't have the patience to do that actually. So you need to just believe me. Okay, so let's talk about logs. Logs are a pillar of modern observability. They have been used since invention of servers, and now, a couple of decades later, they are still one of the most important monitoring data. Why? Because they contain a lot of very useful information. For the security, we can check if there was any security incident, like unauthorized access. That was quick. For troubleshooting, we can get more insights when we have any bug reported. For the performance, to check if our services are running and available. For understanding how the users interact with our application. And also to check what was the chain of events that led to the current system state. So logs are everywhere and they contain a lot of useful data. So what could possibly go wrong if we have logs in place? Maybe you had during your work career such case that there was a bug reported somewhere and the first thing you thought was, okay, I should go to my logs and check what is going on. But you are not sure where are the logs exactly. Because in case of very complex systems, it's hard to go through logs manually. I had a bit different issue. We had a bug reported by a customer, and I knew exactly where I should look for the logs, but when I logged into the machine that was affected, the logs were not there anymore because the file rotated. And this can be even more common case nowadays when we have those short-living containers in place. Even if we are able to spot some issue manually in logs, for example, we found an exception and we want to create a ticket for it, the first question that we need to answer is what is the impact? So how many customers are affected by the issue? Is it still going on? And it's very hard to find this information manually. And even if we'll be able to do that, it will take a lot of time. And by this time, the application could go down, making our clients very unhappy and leaving the feeling that the system is unreliable. To address all of those issues, we should have log monitoring in place. Okay, so now when we already know that we should have it, let's talk how to do it right. So there are three main challenges that we should take into account when we deal with the log data. The first is the volume of logs. So modern systems generate a large volume of logs. They can be just like enormous. And frequently, it's even hard to predict how much logs our systems are generating. Sometimes we are finding this out when we are starting to send those logs to some external monitoring tools, and we are receiving just a notification that there was some limit exceeded or that the license was consumed. And we are currently observing that there is demand to store not only gigabytes of logs each day, but even terabytes of them. And for this reason, when we are looking for some monitoring tool, we should take into account that it should be scalable enough. Even if our systems are not producing so much data currently, it can change in the future because of the product growth or because of some legal requirements. The second challenge is the variety. So different sources produce logs in different formats. And they can be well structured, like for example in case of JSON, when we have clear value pairs attributes, and this type of structure is the best for further processing by monitoring tools. But the logs can be also like semi-structured, like in case of syslog or common log format, when we have just a text log, but it's following a well-defined pattern. But in many cases, we are just dealing with custom logs that don't follow any pattern, and it's still possible to add some processing rules that will create this structure, but it means a lot of manual work on the developer side to do that. Okay. And it would be obviously the best to have logs written in one common format, but it's not possible right now, although the good news are that there are some efforts around creating standards for doing writing the telemetry data. And one of them is OpenTelemetry that creates semantic conventions that define how we can name our attributes to have one consistent format for all logs. So did you had a chance to work with the OpenTelemetry? You can raise your hand. Okay, there are some people. So for the ones who didn't have a chance, I really encourage you to take a look on it. It's an open source project. And the last challenge that we have is the velocity, so the speed of logs generation. Logs are generated in real time, and they should be also analyzed in real time, because we would like to minimize the mean time to repair and the time when our system is down. Why? Because downtime means revenue loss, so how much we can lose. Here is a nice survey done by ITIC, which is a consulting company. They asked nearly 2,000 of enterprises what is the cost of 1 hour of downtime. And here are the results. So as you can see, for 98% of the companies, it was above of $100,000, and for 23 on the top, it was even more than $5 million. So it's really something that we would like to avoid and minimize. Okay, so now we know that we should have log monitoring in place, and we also know because of the data characteristics, it's not easy to implement it. So I would like to go through the whole pipeline of log processing from the moment that we identify log to the moment that we are getting some metrics, alert, and we are able to do some actions based on it. So the first step is to actually identify log and configure it to be sent to some storage. And although it seems to be pretty easy, in case of complex systems, it means a lot of manual work and then a lot of maintenance when our system evolves. So I encourage you to look for monitoring tools that have functionality of auto-discovery. It works in the way that when we have a host, we can install an agent component on it, and the agent is just running, looking for logs and sending them to some external destination. Additionally, the agent is able to find all the technologies and useful information like resource context and attach it to logs. If we are not able to use log agent, we can still use log forwarders like FluentD, FluentBeat, and OpenTelemetry. What is really nice is that those log forwarders can not only proxy our data to some destination, but they are additionally able to do some processing, buffering, and filtering. So let's take a look on some common architecture that uses those log forwarders. So as you can see, we have on our end devices instances of log forwarders. And although it seems to be pretty architecture, it's very hard to maintain because each change that we would like to do, for example, adding a new processing rule or adding new destination, requires change on every instance that we have. So instead of that, we can add a log collector in the middle, and thanks to that, we will have only one place to change, and we'll also have an easy way to add another destination for our logs. The placement of FluentBeat and FluentD on this picture is done on purpose because both of those forwarders were created to proxy the logs. But the FluentBeat is just a lightweight version with very low memory footprint. It's around 450 kilobytes. It does not support so many processing plugins, but we don't need to worry about it because the FluentD that we have on the collector can do all the processing for us as it supports more than 500 plugins. Okay, so once we identified our logs, we can think about enriching them. Logs can be connected with other types of observability data, and there are a couple of ways to do that. The first, very basic one, is just time-based correlation. And although it's pretty easy and possible because logs almost always contain the timestamp information, it's not very reliable, especially in case of large systems. So what we can do instead of doing this time-based correlation, we can do correlation that will be based on resource context and trace context. So what is resource context? Resource context is basically information about the source that sent the logs to us. And here we have example of a log and example of the Kubernetes metadata plugin for FluentD that extended our log with information about the host, pod, and namespace. So we can use this information further to, for example, create metrics based on it or for filtering our log. Another example of context is a trace context. So this is information about the trace ID and span ID of the request that the log came from. And there are a couple of ways to add this context. Here is an example of a manual way. So we are just using span context from the OpenTelemetry library, and we are adding those attributes manually to our logs. But don't worry, if you would use the agent, it would be able to just inject those informations automatically. So there are just, a couple of ways to do that. The key point here is that we should enrich our log data to speed up the analysis and to allow for better filtering of the data. So once we enrich our data, we can move to the point when we add a structure to the data. So I mentioned at the beginning that logs can be structured, semi-structured, or unstructured, and that the structured logs are the best for further processing. So we can create a structured logs in a couple of ways. The first way is adding structure on source. So we can use frameworks like, for example, Log4j, Serilog, or Winstons that support the structured logging. Instead of just creating a text log message, we can attach to it some nice key value pair attributes that we will then use, for example, for filtering the data. Another way, if we are, for example, not able to add those attributes on the source because we are, for example, not controlling the source. It can be some external application. If the log is following this well-defined pattern, and we have here this example of log. This is log from the Cassandra database, and it's about some dropped messages. Most of the observability tools support built-in processors that are able to process this message and extract some nice attributes from it. So now, after this processing, we can see how much useful information can be added in one log line. Oh, I went here too fast. I wanted to add at the end that even if our logs are not following any format, we can still write those processing rules on our own. But it's not so easy because we need to know upfront that we would need to extract this data. And we know about it in Dynatrace, so we added also a functionality that allows you to do the processing on the query time so that you can just save your logs in a native format and do the processing during query. And now we can move on to storing the logs. So there is one catch about storing the logs. It can be very expensive. So what does this mean? I did a small research to check how much it would cost to store 100 gigabytes of data each day for 90 days and for 1 year. So 1 year and 90 days is retention of the data. So for 90 days, it was from 18 to 78 thousands of dollars. And in case of 1 year of retention, the annual cost was from 19 to even almost 300 thousands of dollars. So it's pretty much. So let's think what to do to not just burn our money. To be able to make the log monitoring more cost-effective, the first thing that we should know is what are the main cost contributors in case of storing logs. So the first one is ingest. So it's amount of data that we are sending to some monitoring observability tool for further processing. The second one is retention. So how long we will actually store the data, because it can be just 1 month, but it can be even 10 years. And the last one is query. So actually accessing the data. Some tools don't charge you for query, but in most cases it means that they will charge you more for ingest and retention. So we can ask ourselves a couple of questions when we start to set up log monitoring. The first one is, which logs do I actually need? Do I need to send all logs to my monitoring tool? Maybe I can implement some filtering. Maybe I can filter only the most interesting logs, like for example error logs or logs that are coming from some particular source. Another approach that we could implement is sampling. So we can just store in our tool only a portion of data, like for example 1 log from 10th. I can give you an example. So let's assume that we have a service that is currently not running. So each request to this service will cause generation of new log. And after a couple of minutes, we'll end up with just thousands of logs. Although for troubleshooting, we need to have only a couple of them. So we could just implement sampling that would store only 1 from 10 of identical logs. And it's cool that the log forwarders also support plugins that allow you to do sampling. It can be set for all logs, but you can also do it based on tags. And for example, you can implement the policy that will store more of the error logs and less of debug logs. The next question we could ask ourselves is how long I actually need to store my data. Is it 1 month, on 1 year? Maybe it's different for the different log sources. So let's just not store too long the data that is not useful anymore. And the last question is how frequently I will actually query my data. Because if it's not so frequent, maybe it's worth to take a look on monitoring tools that charge you less for storing the data, but charge you additionally for using it. The bottom line here is let's not pay for the data that we don't need. Okay, so we have our data identified and reached. We have nice structure. The data is already stored. What we can do now, we can create metrics from our logs. And metrics are really nice because they give you a quick overview what is going on in your system. And additionally, they also can help you make the storage of logs more cost effective. Why? Because we can send our logs to some external tool. We can create metrics based on them. Based on those metrics, we can create alerting. We can store our metrics and alerts, but we don't need to store our logs. So if you are not caring about each individual log, you can just ignore it, or you can implement some additional filtering, and based on some additional attributes, you can decide if this is log that you want to store. There are 2 basic types of log metrics. The first is just counter-based metrics. So they are pretty easy. They are just counting the number of occurrences of log that matches given filter. So here, once again, we can see example of log for Cassandra. It's about the dropped messages in Cassandra. And based on it, we can create a metric that will nicely show us the spikes in those drops. The second type are distribution-based metrics. Couple of slides ago, I've shown you this the same Cassandra log that was after the processing. And now we can use those attributes that we extracted from it. And based on one of them, for example, the latency in milliseconds, we can create log metric to show how this value changed over time. Additionally, we can use another attribute as a dimension of our metric to check how the latency was changing for different types of messages in Cassandra. So the bottom line here is that let's generate metrics because they give us a quite nice high-level overview of our system, and they also allow us to make the log monitoring more cost-effective. Okay, so the next thing we can do, we can configure alerts based on our metric. So we can just generate alert each time when our metric value is above of some baseline. But at the beginning, we need to think what threshold we would like to set. So if we would just take a look on the initial data that we have for this metric, we could set the threshold for the value around 20 milliseconds. By the way, this metric is showing the latency. But then when our system gets more load, the value of this metric changes. And in the end, we have a lot of alerts generated. And this is something that we would definitely like to avoid. Because when we have a lot of alerts, we will probably ignore them and we'll try to just live with them. Did you had such situation at your work that you had some alert generated and you said, oh, that's probably nothing important? So what we can do to avoid this? The first thing is usage of auto-adaptive thresholds. So for the same metric, if we would use auto-adaptive threshold that is based on the historical data, after some violations, the threshold value would be updated to avoid generating more alerts. One more thing that we can do is a sliding window. So we can use this window to configure how many times in this window the metric value needs to be violated to generate alert. And it's also something that allows us to avoid this very aggressive alerting policy. So we don't want, for example, to have a single violation that would create already an alert. So the key point here is that let's configure alerts, but let's make them adaptive so that we would avoid this over-alerting issue. Okay, and once we configured our alerting and metrics, we can think what we can do with all of those informations. And the first thing we could is automation. Many modern companies need to deal with the fact that top technical talents are consumed by doing some repeatable manual work. And to avoid that, we could think how to connect APIs that are offered by some different tools and glue them together to do the work for us. So here I have an example. Let's assume that we just deployed new version of a service. So we can schedule a query to our monitoring tool that will check if there is any error rate increase. And if there is one, we would like to trigger self-healing, which could be, for example, installing a version, the previous stable version of our service. And for that, we can use Ansible Tower API that enables to launch some job. It also enables to check the status of this job, and based on it, we can, for example, use Slack webhook to notify some users that there was some issue and it was resolved or not. Even if we are not able to create those self-healing automation, what we can at least do is creating new tickets and triaging them. So once again, we can have a schedule query to our monitoring tool that will check if we have any log that has level error and some additional attributes. Then, based on the context data that we added, for example, name of the service, we can retrieve from our database that we have the list of owners of this service. Then we can go to Jira API and execute a JQL query that will show us if there is any ticket already existing for this issue. And based on the response, we can decide if we would like to create new issue, or maybe we would like to just add a comment that there is additional impact of this issue to the existing ticket. And in the end, we could use, for example, Jira and Slack integration to notify the users about it. So we can write this on our own, add some glue code to connect those APIs, but I also encourage you to check out the workflow functionality that is offered by Dynatrace, as it contains really nice graphical editor that allows you to create all of those automations without writing any code or with very low code usage. Okay, and the last thing that we can do if we are not able to implement automation or triage of the issue is at least to add some guidance. Because in many cases, the issues are repeatable. And when we add those step-by-step guides, it will definitely speed up further analysis of the issue. So the key point here is that we should automate as much as we can. So we should create a self-healing automation, a triage of issues automation to avoid this repeatable manual work. Okay, so we went through the whole journey from the moment we identify logs to the moment that we took some actions based on our log data. And I think something broken here. Sorry for that. Obviously, it's not working just right now. And I would like to go to the conclusions. Okay, we are here. So by mastering log analysis, we can transform our raw log data into some actionable insights. And it's not just about finding the answers, it's also about asking the right questions. So how to use our log data and how to automate based on it. So here are the key points that I would like to emphasize. So let's not just send to our monitoring tool all the logs that we have. Think about the monitoring goals that you want to achieve and configure your log monitoring based on that. Enrich your logs with as much content as possible because it will allow you to get more insights in the end. It will allow you to do better filtering and troubleshooting analysis. Think about metrics that we could generate from logs because they give us really nice overview of what is going on in our system, and they also allow you to make the log monitoring more cost effective. Configure alerting, but make it as adaptive as possible to avoid this over-alerting issue. Because among all the noise with so many alerts, you will just won't be able to spot the really important ones. And at the end, try to automate the self-healing and the triage to speed up the resolution and to minimize this cost of the downtime. Okay, so now it's time for questions.